This is the most popular model I have ever designed in my life, and I think for two main reasons. It's easy to build and it works. In matter of fact, it works so well that this is downloaded thousands of times and have appeared from other YouTubers' videos. But also this Planetary Gearbox is not perfect. I had some small design flaws. Some of them I noticed and some from the feedback that you guys pointed out. Now improved, Planetary Gearbox is stackable. This is also the reason why it has been so popular. Simply saying, you can print this gearbox with one stack and having 3:1 gear ratio, or 2 stacks having 9:1 gear ratio, or 3 stacks with 27:1 gear ratio, and so on. If you want, you can stack this gearbox to the moon. But before we can start building, first we have to print all the necessary parts. This time I'm going to print this stackable gearbox with resin by using my new Gears Ultragraft Reflex 2 and their high quality engineering resins. To be exact, I will use 2 different types of resins. The housing will be printed with transparent PAT10 resin and will be coated with their new gloss glaze. This makes the transparent printed parts actually transparent. PAT10 is actually extremely tough resin, one of the toughest resins you can use for mechanical purposes. And the planet carriers and gears will be printed with friction resistant resin, PAWR10. I was considering also ultra tough resin. Both of them would work, but because I have printed and used this gearbox before, and thanks to your guys' feedback, the friction resistance is more important in this case than the toughness. If you have watched my videos, then you know that I'm not the biggest fan of resin printing. But I'm more than happy to do it because the Gears printing environment is just so good. They know their products, and only thing you have to do is to select what printer and resin you are going to use. All the settings and other stuff is already figured out by Gears, and you just have to start the print. I'm using their latest printer, Ultragraft Reflex 2. There is also a Pro version that is a little bit bigger than this one. It has some upgrades and new features compared to the previous models. Most noticeably, the scraper. This mixes the resin before every print and makes sure that the resin is evenly heated throughout the resin tank. Also, they have improved the print speed and quality. User comfort is same as the other printers because this was already spot on. My first print with this printer were gears and spacers for the gears. After removing supports, washing and curing them, the result is, well, you see by yourself. When I finished printing all the things with PAWR10, it's time to move to the transparent resin, and this one is interesting. Look, I told before, the gearbox casing will be transparent. When I finished the printing, first I again wash and cure the parts, but at this moment you cannot really see through them, and this is completely normal. But Gears have now new product, gloss glaze, and this will make the transparent parts truly transparent. So I took the brush and painted the outer and inner walls with gloss glaze. Be noted, Gears recommend to spray the gloss glaze instead of brushing it, but I don't have other choice right now, so I have to use a brush. When the first step is done, we have to cure it. So it goes to the cure station, and we will bake this with 60 degrees for about 3 to 4 minutes. And then the result is here. This is clearly way more transparent than it was before. Because I used a brush instead of spray, the uneven brush marks distort the result a bit, but still it's way better than before. But now it's time to assemble all those things to one stackable Planetary Gearbox. It starts by press fitting 4x13x5mm bearings to the Planetary gears. Note, you can go around them if you don't have those bearings for some reason. You can print the gears without bearing slots or use the spacers as friction bearings. But don't do this when you FDM print this gearbox. This wouldn't work. This is the moment when the extra friction resistant resin comes in handy. But because I have access to those bearings, I'm just going to use them. So if this step got nicely done, I connected the gears to the planet carrier with M4x20mm bolts and lock nuts. It's important to use lock nuts, by the way. This should look like this. I repeated this more 2 times. Now we start with stage 1. Place the planet gears to the first stage housing. Then secure the stage 2 to the stage 1 with M4x40mm bolts. It's important to use those holes where the bolt heads can fit in. Then again place the planet gears to the stage 2 and repeat, till you have your desired amount of stages, aka gear ratio. Like I already told, I use 3 stages. To finish this off, we need the end cap. Again 3 M4 bolts and the gearbox is completed. Almost. Currently we don't have input, so I decided to borrow this from the old version. This area didn't got redesigned, so it's completely fine to use this one. And I think we are all set. Let's see, does it even work? Well, right now there is a problem. I didn't lubricate the gearbox because I just forgot. I took the gearbox apart and assembled again after I added some silicone oil. Now it works way better. Like we saw, the gearbox works, but there were no load, so let's torture it a bit. Gearbox is mounted to the wood plate and it will turn 20mm aluminium shaft, which is connected to the gearbox output. When the gearbox moves, it will turn the rope that is connected to some amount of weight. Gearbox will be driven by 4S LiPo battery and that speed controller. If the weight leaves the ground and gearbox won't break, then the test is passed. If not, then not. We start with 5 kilograms. Let's see will 3-stack gearbox can lift this up. This didn't look like a problem, increasing weight to 8 kilograms. No difference. Next, 10 kilograms. I had to give a little bit more power to the speed controller, but still not touching the limits here. Next, let's do a bigger jump, 18 kilograms. Okay, definitely harder. Still passed, but we are getting close to the maximum load. Let's add another 10 kilograms, aka 28 kilograms in total. Yeah, this is too much, but still it managed to lift weight from the ground, which is already pretty nice. But it was too much because look the smoke. Moving on to test 2. Test 2 is torque test. I connected one piece of wood to the gearbox output. You see the markings on the wood. Every line shows every 5 centimeters from the center of the shaft. I apply 5 kilograms to the first line, and then move the weight farther away by 5 centimeters each time. Starting with 5 kilograms at 10 centimeters. Next, 5 kilograms at 15 centimeters. 5 kilograms at 20 centimeters. Five kilograms at 25 centimeters. 5 kilograms at 30 centimeters. This was harder, but still it passed the test. Now 5 kilograms at 35 centimeters. This is on the edge of passing the test, but I think it's fair to say 35 centimeters is the limit here. But still I tried 40 centimeters too. And yeah, this is clearly a failure. So for the torque test, the limit is 5 kilograms between 30 to 35 centimeters. Guys, don't forget, this model is free to download. So if you need 3D printable gearbox, give this a shot. Also big thanks for Hey Gears for making this video possible. But for now, thank you for watching and see you guys next time. Bye.